Hello, everyone. Again, thank you for coming. So I think we got a very good collection of questions from the Google Doc. So we'll go over one by one with you. You can also refer to the Google Doc so you can see what questions are being asked. But I try to make it very self-contained on my iPad so we can focus on my iPad only today. Okay. The last time I checked, the Google question was about maybe 3 p.m. So if you put your question later than that, I can maybe cover them maybe tomorrow. We got another question, Q&A session tomorrow. Okay. All right, so about lecture series number 2, I would say this is quite an important lecture series because you have to learn about how to use object copying and also deep twin, also how to use O keyword. I think that's really one of the most important learning outcomes from the first few weeks. So you can apply that to write complete contracts. So I'll just try to go over the question you have. If there's anything you want to ask, also put on the chat or just speak out, okay? We'll see how things will go. If I can really have some time left, I can possibly maybe reserve maybe the ending 10 or 15 minutes. If you got questions related to lab 1, I can also answer. Okay, but we'll see. But the main focus for today should be about the lecture. Okay, I want to make sure you have no question about it. Okay, all right, let's start. Okay, so the first question there from the Google Doc. Okay, so the question is, I think this question comes from the modularity lecture there, where I show you one very sophisticated architecture diagram, where I actually mentioned something called client-supplier and something called inheritance. Okay, so the question really is how you can distinguish between which arrow is for client-supplier and which arrow is for inheritance. Okay, and then this purely depend on our design. Okay, I'll try to answer quickly. You will be given a special lecture, short one actually, maybe either in week number 4 or week number 5. In your upcoming lab number 4, your upcoming lab number 2, if you see the grading scheme, you will be required to draw a design diagram based on the implementation, okay? Especially we're gonna use the iterator design pattern for your lab number 2, and that will be covered in a lecture as well. So you will have to practice drawing what's really the precise relation between classes, right? That's something you will get more detailed later. But today, I just want to answer this question here by giving you some example so you have some intuition, first of all. Okay, so now, let me just show you here. So I just kind of summarize what you should really know about design diagrams, okay? So it's very important for you to know how to draw design diagram. The notation you actually use may not be a secondary issue because you might use UML, you might use other notation. The notation we use is kind of similar to UML, but we have some clearer notation. And also you can include contracts in your diagram. So that'll be the detail that'll be covered later in the lecture. But for today, I just want to give you some intuition quickly about how you can draw diagram, okay? So I think what's really the purpose of drawing a design diagram? Number 1, it will be representing an abstraction. So for those of you who actually already watched the modularity lecture, so whenever I talk about abstraction, the easiest way for you to think about abstraction, every time people talk to you, what's the abstraction for this particular piece of code, right? So abstraction simply means it's like a version of code with details hidden. Apparently, this definition is a little bit vague over here, but it's intentional. So you might be wondering, what kind of detail should I hide from external user? I would say it's completely up to you. So when you draw your design diagram, to what extent of details you want to show on your diagram is completely up to you. Of course, for your very first design diagram for lab number 2, we'll give you more precise guidance. But later on for your lab number 3 and also for your projects, in which case you have much more freedom about the classes you can create and also the contract you can write. In that case, you have to be selective in terms of showing to the TA or to myself your design. Okay. Anyway, so abstraction, that's a really important word to actually know, abstraction. And then usually when you show the diagram rather than showing a piece of code, either Java code or IFO code, it will be better for communication for somebody who has no programming experience, or for somebody who doesn't know about IFO, somebody who doesn't know about the language you're programming in. Showing a diagram is a much more desired idea rather than just showing a piece of code. Okay, so that's about the 2 main purposes for using a diagram rather than using a piece of code. Okay, so these are the 2 purposes. Okay, so now let me talk about just give you one example. So this example is pretty nice because it will actually show you all the both kinds of relations you can have among classes. Okay, so now let me just go over with you here. Let's say this is my piece of code that I developed for whatever project I'm working on. Let's say we have one class called savings account. Okay, let's say in your lecture series number 2, you talk about bank account, right? But let's say we got another account over here called savings account, which is more specialized version of the account that simply inherits from account. Okay, and then ... here simply means I'm omitting other parts of the savings account just for abstraction purpose. So I only show you the relevant details for the code. Okay, and then let's say we got owner over here of type clients. So now I'm not really writing the definition for client class, but you can assume there is a class called clients somewhere. And then we got TS, which could be a query, could be an attribute. Let's say it's a query. Okay, it's simply an array of transaction over here. Okay, so that's the class I want to show you. And now the challenge is, if I want to communicate this particular relationship over here, the textual definition for this class, how can I visualize it to somebody who doesn't know about iPhone or somebody who doesn't know about Java? If you got a corresponding Java class, how can we do it? Okay, so there are basically 3 things I can identify over here. Number 1, I can see that there is a inheritance relationship. That's something I can draw in the diagram. Number 2, I have this particular client-supplier relation. If you recall what you did in quiz number 1, I kind of show you 3 classes over there, A, B, and C. And then I said in lecture series number 1, whenever you declare a class being the type of some objects, in that case, this class is a supplier, right? That's what we said before. So you can think about this already a client-supplier relation over here. So you can think about this is some supplier, which is called clients. Well, it's a little bit confusing, but the supplier's type is simply called clients, right? And then for this particular TS over here, this one is more interesting. I'll try to disambiguate a little bit more carefully when I give you the formal lecture. But for now, you can think about, for this particular supplier over here, you can say it's an array type, right? So array is definitely the supplier. But at the same time, you can think about transaction is also a supplier. So you can think about, in some way, we really got 3 suppliers over here. Which supplier to really show in your diagram is, again, completely up to you. If you want to show them all, do it. If you don't think you should show them all, you should only show a selection of them. Okay, let's try to show some, and then I'll give you the idea. So now, how can we draw the diagram? First of all, you can try to say for every class that's involved in this particular design, and we want to just use a circle to represent them. Okay, so we have savings account. That's actually one of the class. So I will simply do, the convention would be you're going to draw some oval arrow as an oval shape, like a circle. Okay, so now I'm going to put savings account over here. Okay, just an ACC here. So that's one class. And also we got another class over here, which is a parent class. That one there is called account. So I'm going to draw another circle over here. So this one here is called account. And we know that there is inheritance relationship between them. So now how do we draw that? So we're going to say, so the arrow, the direction of the arrow is really important. You will point from child to parents. So, and the convention then, usually for the color, is going to be red. So we're going to draw a single line arrow over here. So this is inheritance. So whenever you see an arrow like this, it usually is actually from bottom to top. This is vertical. Normally, we don't really show inheritance in horizontal, but sometimes maybe you got many classes to show, so you may have to compromise. But I would say typically, inheritance should be vertical. Okay. So now, whenever a client, whenever somebody saw this diagram here, they should know you're basically saying you have one class called account over here, and also you got a specialized version called savings account. Okay, so you can see it's a very different way of visualizing. It's a very different way of representing the relationship between classes, right? Either you can say inherits or you can draw an arrow. Okay. Okay, let's take a look at the client supplier very quickly. So let me just try to show maybe 2 of them. Let's say for this one here, you can see for this line here, we're saying that we have basically got an owner of type clients. So first of all, let's just draw the supplier class over here. In that case, I'm going to maybe put it here. Okay, just another arrow, oval shape here, supplier. And then That's of type clients. Okay, and then for the client class, apparently the client is the supplier, right? And then the savings account is the clients. Okay, so we got supplier, we got a client, right? So now, in order to show a client-supplier relationship, we have to draw a double line arrow. Okay, so something like this. So it's going to be a double line arrow, and if color is allowed, you can use green. Okay, I'm going to show you the convention a little bit later in the formal lecture. Okay, so there's a client-supplier arrow. So the question was, how can we tell? Let's say if you simply just print out black and white, maybe you will not be able to tell the color. However, usually for client-supplier relation, you also have to put above the arrow over here, the supplier name. In this case, the supplier name will just be owner. So you simply say owner over here. So what this is saying is we have a client's class called savings account. They actually got an owner supplier of type clients. That's what we are saying here, right? So this line here, that's in the programming text, has been visualized as this particular client-supplier relationship. Okay, and then we can do another one if we wish. But this one here, I'll leave that open now because you will learn about how to do collection in different flavors when you actually receive that formal lecture I'm going to give to you, either week 4 or week 5. I don't know yet. Okay, okay, it's a very quick response. Sorry about that. I should really close it. Okay, so any question about the design diagram over here? Any questions?
Oh, Professor?
Go ahead.
Can I say the client's class client is saving account?
Can you say this is, yes. So let me make it clear here. So when we talk about client-supply relation, right? So the arrow over here, the left-hand side of the arrow should be the client class. In this case, the savings account, because in the context of this particular class, I'm declaring this particular attributes. That's why it's a client's, okay? And the other end of the arrow over here, even though it's called clients, but this is the supplier, this one, right? This is for the role of the supplier, because this particular class is being used as the type of the attribute. That's why it's a supplier type.
So it don't have to call a feature, then it's become a client for the account, right?
So I would say the way for you to judge whether there's a client-supply relation, you only look at the declaration.
Okay.
Yeah. Maybe what you're saying is this. So for example, let's say maybe somewhere in the savings account, for example, right? You might say something like owner dot, for example, append is a string, right? Maybe owner the append something over here. But yes. So okay, good. This guy over here is not really declaring any client-supplier relation. It is not. What it does, let me just be clear about this point here. You can think about this particular declaration here. Let me put it here. So this one declares a client-supplier relation. It just declares that. On the other hand, this particular line, somewhere in the implementation, let's say in your code, so this one is really making use of client-supplier relation, which we just declared previously over here, right? So in the design diagram, you only show declaration. You don't really show the usage of the client-supplier relation. If that, maybe that answers your question, I hope.
The question is actually coming from the quiz 1, the question from the quiz 1.
Yeah, if you want to talk about quiz number 1, maybe speak to me during the office hour, and then we can go over that specifically. But I can tell you that I know for quiz number 1, I did ask you about the various terminology about what's the name of the supplier, what's the type of the supplier, and what's the function of the supplier, right? So for that one, I can refer you to the microwave example that I talked about. So you will find the answer there. But if you want to go over the quiz number 1 with me, drop by my office hour.
Okay, thank you.
All right, good. But guys, I think that this is more like a continuation from what we covered in week number 1. For week number 1, we just talked about what's the difference between clients versus supplier. But now, in the later weeks, especially for lab 2, you're going to say, given a piece of code that you wrote by yourself, you have to somehow present an abstract view of your code or your design. In that case, you have to decide, number 1, what classes do you have to show? And number 2, what inheritance or what client-supplier relation you want to show. You want to be selective. But of course, for lab 2, we'll give you some concrete guidance. But later on in the project or in the later lab, you have to decide what classes you want to show. Okay, any more questions about this design diagram here? Okay, good. So now that's about the design, the modularity lecture here. Just that's the only question I saw. So all the rest of the questions is really about the writing complete postcondition, especially object copying and how you can use the O keyword. Okay, so let's see. Let's do as much as we can by 7 o'clock, right? I'll try to maybe reserve maybe 10 minutes for you to ask lab 1 related question, and I can carry on with the Q&A maybe tomorrow. We still got tomorrow as well. Okay, so now let me just present to you the question, and then I'll explain that. Okay. The question is, for shallow copy, what happens if an array stores primitive type? So if you recall the example about array copying that I did in the lecture, so that one there is like array of string. Apparently string is a reference type. It's not a primitive type, right? So, okay, that's a question there. What if you got an array of integer? What happens if you do a shallow copy of an array of integer? What's going to happen? I'll get there, okay? And then, so that's an example your colleague is suggesting. And then, apparently, if you try to visualize what's an array of integer, you don't have any addresses. It's primitive type, so you don't have any arrow, okay? And then, okay, that's just the suggestion he's making. Okay, so let's present the question here. So this is basically about a shallow copy example we did in the lecture. I modified that a little bit, so just to make the question more relevant, okay? So now let's say this. So the modification I made was this. So let's say the imp and old imp, right? Remember we had that for the lecture. So now let's say rather than an array of string, it's going to be an array of integer, okay? So now the difference is, so now the integer over here is a primitive type, in the sense that there will be no addresses, just the values, right? Like pretty much like in Java, okay? So now what happens when we say old imp is assigned to imp.twin? I would say in this case, it's quite easy to see. First of all, we know that the very first step for the twin to do is to simply just create a new objects, right? The first step. So it's going to be an array of integer. Okay, I'll just say array of int. And then it's going to be, and now what about for every elements? For every elements, the way to do it is by saying, let's say this is eventually going to be assigned to old imp. Eventually, right? So now, how do I copy these 3 values from these 3 values? That's the question, right? So if you look back to the slides, the definition goes like this. Let me write it down here. So now for the old imp, so we got 3 elements in the array. Let me just do the first one. Index 1, it will be simply use simple assignments, right? It's assigned to imp at position 1. So now, what's the effects of doing this particular assignment here depends on the type of value that we are talking about. So we know that imp1 over here is talking about just an integer. It's a primitive value. So there's no address to copy over. So in that case, we are just copying over the entire value of 46 into here. So that's what we're doing. So there's no, like what's said in the question, there's no arrow, right? So that's an accurate description over here, okay? And then, so we also got something for 69, just copy, and also we got 75. So you can think about these are simply different copies of the primitive value, even though they are the same, okay? So now let's say the following. If I say imp at position 2, imp at position 2 over here, change that to 23. You can see there's no aliasing, of course, because we only got primitive values. So changing this is not going to affect this. So it stayed to be 69 over here. All right, so now if we try to evaluate this particular cross notation, so now hopefully you can see how it should be evaluated, right? So now we know that in total it's going to run 3 iterations. Let's try very quickly, right? For iteration number 1, imp at position, so j is going to be 1, 2, and 3. Imp 1, and then old imp at position 1. Well, that one is quite easy, right? So 46 and 46. So that one there should be true. Okay, no problem for that. And similarly for element number 3, right? 75 versus 75, they're also the same. What about the second element there? the second element would be, let's say imp at position 2 equal to old imp at position 2. Well, in this case, we're comparing 69 against 23, right? So that would be false. So overall, across all, it's going to give you false because you have modified already the primitive value from the shallow copy, right? One more thing to say before I can take any question from you, okay? When you try to compare primitive value, okay, let's say I and j, they are simply of type integer, okay? Normally, you will simply say I equals j. That will give you a Boolean. Although it wouldn't be wrong if you also say I tilde equal to j. Effectively, when you say I tilde equal j, if they are both primitive value, let's say it's integer, they will simply just be effectively the same if you just call equal. They are the same. Okay. Of course, for reference type, it will make a difference. For reference type, this will be comparing references, and this will be calling the is equal that's redefined in the corresponding class, right? So notice that difference. Okay, so that's about the first question over here, and the question really is about what if the array that we talk about over here is a primitive array? In that case, it's not difficult because it doesn't matter if you do a twin or deep twin. The object visualization looks just like this. Because when you do a deep twin of integer value, it will still give you just the integer value. There's no object structure over here. So there's nothing about recursive copy. Okay. Any question about this? We okay? All right. Okay, guys, feel free to interrupt me, okay, if you got any question, okay? Okay, now the next question here, okay, is something about deep copies, okay? Let me read the question to you. For the deep copies in the IFA code example, basically the array copying example there, you know, about oimp and imp. So after the initialization of oimp, so oimp is assigned to a deep copy of imp, basically, okay? And then before any changes is happen before that, why are these all true? Okay, first of all, that's the first question there. And then actually I want to praise for whoever was asking this question here because they did try to actually run this in the debugger, and they will see that the expressions really show you that they'll simply give you true. So I really do encourage you. So in order to study lecture series number 2, you may actually want to run the 2 example code I gave to you. Try to see that in the debugger. So one of the later questions about how you can run the debugger for across. I'll give you some tips about that as well, but that will come later. Okay. So now, and then, so this is their question. Knowing that these simply compare to true, that's question number 1. Okay. Question number 2. Given that the object comparison is simply just false, why would the tilde over here give me true? Because when the object comparison over here is simply false, that would mean you're only comparing references. Okay, guys? And first of all, I want you to understand what your colleague is really asking. Okay, so object comparison is false. So why would this still be true? Since so this tilde should just call comparing references. And then I want to answer this question right away. Is the string class treated like a primitive type in IFA? No, no. Okay, this one I can answer you right away. No. String class, just like in any other programming language like Java, string is simply a reference type. So primitive type in IFA is just like a real number, Boolean, character, or integer. Okay, it's the same. So there's no inconsistency here. Okay, guys, let's now take a look at this question here. Okay. Assuming that you kind of understand what your colleague is asking, so I can see a little bit of confusion over here. Okay. When you actually try to run, for example, run this particular comparison over here, it is actually different from if you say imp tilde old imp. They are different. Okay. Before I move on to some illustration for you, which will be rather easy, can anybody try to tell me this tilde over here? Let's call that number 1, and this tilde over here, let's call that number 2. Will they be effectively the same? Are they basically calling the same is equal feature under the hood or not? 1 versus 2. That's really basically the essence for the question. Are they really working the same way or they're working differently? That's really the question. Anybody want to try?
No.
No. Okay, good. Why not?
Because for the second one, it's comparing the attribute in the object. But for the first one, it's comparing the reference of the object.
Not really. Not really. A good try. Okay, what you're saying is for the second one, you're comparing attributes, like you're comparing objects. But for the first one, you're comparing references. Not quite. Let me make my question more direct. Okay, we know that whenever we have tilde over here, in turn is going to call the is equal query, right? Pretty much like in Java, it depends on which equals method you're calling, right? So now, can you tell me, in this case, from which class are we calling the redefine is equal? And for number one, from which class are we calling the redefine is equal? Are they calling the same is equal, or they are calling different is equal? That's my question.
For number one, it's calling is equal from the array class, but for number two, depending on what the content is, so if it's string, then it's calling is equal from the string class.
Aha, Ring, thank you. Exactly right. So what Ring said is exactly right. So now, the imp and also old imp. So guys, I think that this might also help you later on if you want to use a comparison for your labs or projects. So now let's say, assuming that just the same as your lab, as your lecture. Let's say old imp and old imp, they're simply array of string. So for number one over here, I can also see the chat over there from Siet. So also you're right, okay? So now over here, this is calling the is equal from array. The is equal from array. On the other hand, you can see this tilde over here is comparing imp at position 1, which is of type string. So this tilde here is the is equal from string. So the original question, if you read it more carefully, so over here, when we compare these two strings, it has nothing to do with what's the object comparison value for these two arrays. Nothing to do with it. Well, we're just comparing that manually, basically. Okay, just to make my point a little bit more explicit for those of you who might still be lost, let me give you more explicit example here. Let's go back to what we said in the lecture. So let's say with the old imp is simply assigned to imp.deepTwin over here, right? So we know how to draw it. Let me just draw that quickly. So it's going to be also imp is now, old imp, sorry. So now the old imp is now pointing to just a brand new array, and the process about how to draw this I already show on the lecture. So I'm just going to draw that quickly, assuming that you're okay with the drawing process. And you got 1, 2, and 3, right? The first one is going to be a new string object called Alan. It's a deep copy. And then the second one is going to be Mark. And the third one is going to be Tom. Okay, so now let's now compare two different comparison. Okay, because the example as I show you, I never say things like imp dot compare object. I never say that, right? So that means object comparison by default for old imp and also imp will just be false. Okay, so now let me just write it clearly for you. Okay, so what we get is okay. So now you can think about over here. Old imp, if you got object comparison should be false. And also for imp, object comparison should be false as well. Okay, so that means when we actually say the first one, when we say imp tilde equal old imp, first of all, we're going to call the is equal from array. And if you remember from the tutorial video, we said that if you simply use tilde between collections, if the object comparison is simply just false, what you will do is you're simply just going to compare their elements by addresses, right? For example, for this particular deep copy here, Alan and the Alan string object here, they're different addresses, right? They're different object because it's a deep twin. So that will be not equal to, right? And also for the second mark and the mark over here, they're also different objects. So that will also be not equal to, right? So this will just give you false. Okay, so hopefully you're okay with this. Now the question is, what if you really wanted to return true because you believe the contents are really the same? In that case, you will have to say before the comparison, you have to say imp dot compare objects, and also old imp dot compare objects. That's what you have to do, right? In order to really make sure this is going to give you true. But currently it is not the case. So I'll just cross them out just for now. Okay, it's not the case. All right, that's about number one. And for number two is if you actually want to compare the contents of the array manually. Okay, in that case, you can simply say use across. So we basically bypass the use of the object comparison to decide whether we want to use object comparison or we want to use reference comparison. That's another way to go. But of course, it's not as convenient as use tilde directly on the array level. Okay. So what this will do is over here, across, you will across 1 until int.count, assuming that they are actually of the same size, right? So now what we'll do is we're going to run 3 iterations on them and then do one by one. So now this particular tilde over here will come from, because the element type is simply of type string. So the tilde will be the is equal from string. Right? Okay, hopefully so far so good. And then the is equal in the string class has been redefined, pretty much like the equals method of the string class in Java, the same idea. Okay, so now if you simply want to compare, for example, let's say the Alan over here and the Alan over here. So now we're comparing their contents rather than addresses. So that will be true for the first iteration. If you compare this mark objects and this mark string object here, also the same content, so that will be true. And similarly for the third one, Tom and Tom as well. So the whole thing over here is going to return true. So now that's a subtle difference you want to watch out for. Okay. Okay, I see some question, some remark over here. Okay, good. So basically, Colette, you're basically just saying this help you clarify. Yeah. So yeah, you're right. So I only talk about object comparison in the Lab 0 tutorial video. It's a very subtle details for the language, of course. But as I said before, every time you learn a new language, it doesn't have to be IFO. Any new language you learn, there will be some subtleties you have to watch out for. So I did mention that in Lab 0, it's okay if you simply didn't realize that has an effects in a different context. That's okay. So hopefully it's not clarified for you. All right. All right, guys, any question about this particular example before I move on? Okay. Actually, I like you guys' question. That's good. All right.
I have a question. It's not directly to the example, but the idea. First, before I ask the question, are you able to iterate through a string, like compare, let's say, every
character
letter in a word? Yeah, every letter.
Okay, good question there. Okay, okay, let me answer your question first. Rain, that's a very interesting question. Let me just check one thing. I believe you can, because you can think about string being an array of character. But let me double check one thing so you can see how I'm figuring out. Yes, you can, because in string, they also got something called item. You can think about item is like a char at in Java, right? Character at. Okay, so you can do it. Let me just give you one example. So let's say this. If I have, for example, let's say, if I have, for example, Alan, let's say that's S1. I got another string over here, also let's say Mary. Okay, let's say I want to compare to see if these two strings are the same. Apparently they are not. Either you can say S1 tilde S2. That one there is, of course, is going to give you false. No question about it. What if you want to encode the equality manually yourself? You can do the following, okay? You can say across, and then let's say we want to go across the indices, right? The indices from 1 until also the count for the size of the string. Oh, think about Alan over here, thinking like this, conceptually. It's like an array of size 4. And then 1, 2, 3, 4. Those are the indices, A, L, A, N, right? And then for S2, it's just another array of characters. And that one there would be, let's say, M-A-R-Y. Okay, so hopefully that makes sense. And then you can say 1 until, let's say, S1 dot count. Okay, I will try to, I will do a little bit more trick a little bit later. Okay, let me just write this down first. 1, and then let's say is, let's say index, I'll just say I, okay, index I, assuming that there's no clash. And then in order for me to make sure every character is the same, I should really use all for universal quantification. So now I can say S1, you can either say S1, the item over here, and then you can say I here. And then it's a character, it's a primitive type, so you can simply use equal. You can also use tilde if you wish. And then for S2, so I just want to show you another notation. You can use a square brackets. It's like an array of character that you want to go to index I. Okay, either way works. Okay, guys, I have a question for you. Okay, so now let's say this, right? So now you can see I'm doing this. It will work because S1 and S2, they are of the same length. What if I have the following? Hypothetically, let's say S1, rather than being Alan, okay? What if S1 is, for example, let's say, I'm looking for something that's more than 4 characters. How about Sarah? Okay. So now it could be a quiz question, guys. How about this? Let's say it's a quiz question. Okay. What's going to happen if I use these 2 string values and then I run this across loop? Is it going to return true, false, or something else? Anybody? I'll let you think. I can pause a little bit. Think about it.
I think it will be an error because you're comparing void.
It will be an error. Okay, that might be on the right direction, but when you say void, not really void. Okay, I can see Krishana. Sorry, I don't know how to pronounce your name. Pardon me. So some violation, some precondition violation. That's pretty good. So what kind of precondition violation, Ovik? What precondition violation are you thinking about? Index, okay. Basically index too large, contract violation. Okay, good, very good. Let me, for those of you who may not have been following, let me just tell you, okay? Think it this way. Now in this case, if we say S1 is simply Sarah, okay? So it's gonna be, let me just put it explicit for you guys. So 5 over here, and then S-A-R-A-H, okay? And now, for that particular example there, S1.count is 5, right? So that means we're going to run 5 iterations. So what OFX is saying here is exactly right. So to be more precise, for the very first 4 iterations, you're okay, because you're comparing S against M, A against A, R against R, A against Y. But when you go to the 5th iteration, what you will get is S1 at position 5 equals S2 at position 5. To evaluate this is easy. It will just give you H. But how do you evaluate this? You're going to get almost like an index out of bound exception in the Java sense. So if you try that in IFO, I think something like index too large, contract violation, okay? So if you look at the indexing notation for array, it has one of the precondition being the index cannot be too large. So OVEC is exactly right, okay? So you will have a problem over here. So that means our across loop over here is not being very general, because in the case where if the one of the array size is actually larger, you might run into this particular contract violation, which is unexpected, right? So now, how can we fix this? I pretty much like the across loop, so we don't necessarily have to change the across loop per se, but I still want the whole thing to be a single Boolean expression. Guys, any suggestion how to change this? Any suggestion? I want to add something here without changing the across loop so that I can compare any string in general of any length. I can even compare maybe empty string against empty string, maybe empty string against non-empty string, right? I want to consider all the cases. What do I need to add over here? Okay, Chi-Ming, you said if I is less than A2.count. However, that one there may not be really, it's not as nice. You're really suggesting that we may have to modify the across loop. There's an easier way. Okay, Ray, you're talking about using max or similar. Okay, if you're saying max, well, basically, if the count of the two strings are not the same, there's no way they are equal, right? Okay, OVEC, very nice. Okay, so let me just write down what your colleague is suggesting. Pretty good. So you can say s1.count equals s2.count. And then, so now, that's also why I want to introduce to you another thing. You have seen this already. I also briefly explained that in the Q&A last Friday, okay? So if you got and then over here, that's equivalent to the ampersand in Java, okay? Very quickly. It's called a short circuit operator, short circuit. Okay, I'm not gonna bother you too much, but let me quickly explain. If you took maybe 2030 with me, I briefly review it, only in the very beginning. But if you took 1022 with me, maybe many years ago, I also try to go over in detail. But anyway, for now, if you got short circuit for ampersand, what does that really mean? If you got one Boolean condition here and another Boolean condition here, right? Short circuit tells you, if you know B1 is already false, you don't need to bother with evaluating B2 because for conjunction, it will be false anyway. Okay, number one. Okay, number two, you will only evaluate B2 when B1 is actually true. Because if B1 is not true, there's no way for the whole thing to be true anyway, right? It's a very quick verbal summary, okay? So now how does that apply to us over here? And then over here is the short circuit version of the logical operator N, okay? So when you do this, you're saying that I will only try to evaluate this particular cross loop, in which case having S1.count and S2.count being the same will be very important. So I would simply put as part of the conjunction like over here, meaning that I will only evaluate the across notation over here if their counts happen to be the same. What if this particular is actually this particular equality actually is false? If it is false, we don't even get to evaluate this to avoid that particular index out of bound contra violation. So that's why having and then over here would be very important. Okay, about a short circuit. Okay, if you're still confused about how the short circuit really works, maybe you can speak to me. I can explain further to you, but I think that might be good for many of you already. Okay, let me look at some question here on the chat. Okay, let me take a look. Okay, so I see one question over here that's really about why can we not use the watch about debugger. Okay, about using to debug across notation. Yeah, it will come a little bit later. It's on my iPad. Okay, I'll make sure I get there. Okay, got another question here from OVEC. Is a character considered a primitive type? Yes, indeed. There's something I want to point to you very quickly over here. If you go to iPhone Studio, so if you go to, for example, integer, for example, so now whenever you go to, if you go to a class where it says the keyword expanded, we'll explain what expanded really, why it expanded would be useful from the modeling point of view. We'll get there when we talk about singleton pattern. But for now, every time if you see a particular class is like expanded, it's basically like a primitive idea. So you will see integer is primitive type, like expanded, meaning that there's no address for that particular value, just a value, no address. And for character, if I go to the character class over here, you will see that that's also expanded. So obviously that answers your question. So character is also a primitive type because it's expanded, okay? All right, let me see a little bit more. Do we have to do S1.compare objects and S2.compare objects? I don't think in the string class, they have this object. Okay, if I go to string, let's confirm together. Okay, they do have object comparison for the string. Yeah, so I would say in the string class, apparently for IFO, the language, they also consider string to be a collection, like a collection of character, like how I did it. However, I would suggest maybe don't really bother with setting up the object comparison for the string, because in that case, you're only comparing character by character. You will compare the character member by their contents anyway. You can never compare the address of a character. So I would say to avoid confusion, whenever you talk about comparing string value, you will just use tilde, right? But I can think about it, how the tilde really works is really like something like this. You can use to check, first of all, their size of the two string must be the same, and also the every character should be the same. I think that might be easier. But back to your question, they do have object comparison. You can look further to see that. Okay. Yeah, another remark over here from Caleb. So you're quite right about it, although I want to say this, okay. It is true for, if you want to compare, for reference type, how about this? For reference type objects, let's say you got object 1 and object 2, right? You can either write object 1 equals object 2. In that way, you're comparing the addresses. Okay, that's easy. Okay. The second possibility is you can say over here, you can say object 1 tilde object 2. In this way, it's as if you said object 1 dot is equal object 2. Okay, and then which version of is equals being called depends on whether it has been redefined already, and also the dynamic type of the two objects over here. Okay, that's about reference type. When we talk about primitive type, and then I wouldn't say object, just primitive type variables for values. And now you can also got two options over here. Let's say I got value 1 and also value 2. For example, they're simply integer. You can definitely say equals over here. In that case, you're just comparing their value. There's no notion about addresses for primitive type, just like in Java. And for number 2, you can also say v1 tilde v2. Okay, that one is still comparing the value. For this one here, it's as if you set v1 equals v2. They are the same. Okay, so you can see which comparison is going to be adopted depends on the context of the object type, right? But hopefully this summarized that clearly for you. All right. All right. So let's see. Okay, that's pretty good. Okay. Yeah, guys, please feel free to put in the chat. I'll try to interact with you on the chat as well. All right. Okay, so that's about this question here. Okay, and then let's see another one here. Ah, good. So that's exactly, I think one of you guys put in the chat. I said I'm going to come to this. The question is like this. Okay. When your fellow student was trying to debug the following, for example, a cross loop, right? Apparently, let's say maybe imp.count is simply 3. So we will expect that if we try to go into this particular body of the loop, we can actually see 3 times, right, for each iteration. However, iPhone Studio wouldn't allow you to do that. I'll show you. I do have some preparation for you. Just give me one moment. And then you will actually see something like error occurred when you try to debug it, right? I'm going to show you. So now the question is, how can you actually debug the across notation? So let me show you. Before I show you, let me tell you the principle. So number one, iPhone Studio does not support debugging of the across properly. Maybe they're planning for some future release on this, but unfortunately, that's the way it is. Okay. However, there are certain things we can do to suit our purpose. I'll show you both according to my experience. Okay. Either you can try to inspect the values of the array in the expressions panel. Number one. Number two, you can try to write some additional front until loop that will be equivalent to the across loop you have. So you can now debug iteration by iteration. I'll show you both solutions. All right. Okay, let me switch to iPhone Studio over here, and I'll show you exactly what I meant. So this is the code that you actually got. Okay, let me show you the code I'm modifying. If you go to lectures page for week number 2, there's a copying of the arrays, right? Okay, if you download it, I'm just modifying on top of it, just a few lines. So you can definitely rewatch the video to add it for yourself, okay? So now let me say this. Let me go back here. Let me just close these classes. Okay, so now if you go to the root class, right? In the root class, it's called test array copies. And then you can go to either one of them. I just should go to the first one, test array of reference copy, right? So let's say this. If I want to debug this particular across loop, I might set a break. I might say set the breakpoints, and then I might try to just go over the iteration one by one. So how do I do it? Okay. Let's now try to debug this particular feature over here. Okay. So you learned about from lab number 0 how do you set a breakpoint. So I'm going to follow the way. You can see there's a feature panel over here, right? Double click, right click, and right click, right? You learned about it in the lab 0. And then let's say I want to debug this particular across loop. So that's why I put a breakpoint right in the beginning. Okay. First of all, I'm going to show you what you will hope that will work wouldn't actually work, and then I'll show you the 2 solutions. Okay. So let me just say run over here. Okay, and then, okay, so now I'm here right before I try to execute the across. Okay, so hopefully everyone is actually comfortable with debugging. So now I'm happy that everyone who come to me to the office hour for help, you also can show me on the debugger. I think it's a very important technique for you to pick up. If you still got trouble, please let me know about how to use debugger. It's a very important technique for you to pick up. All right. So now for this particular guy here, so now if I simply say, let's say. One step at a time, step over, okay? And then I'll say step over again. So you would think if we are currently over here, I should be able to know what the value is for the J, for example, right? Oh, by the way, I'm using the S over here rather than is. So that's why I need to say J.item, right? Oh, we also explained that in the lab 0 tutorial video. So now, if I simply say J.item over here, it's going to show to me under the watch expression over here, error occurred. So that's exactly what you guys ask on the Google Doc, right? That's exactly the error message over here saying error occurred, right? That's exactly what you experience. That's actually normal, okay? And also, if you try also to write, for example, imp at position J.item, that also wouldn't work, okay? So now we need some workaround to really, to be able to debug the cross loop if you wish. Okay, let's see how we can do it. I have 2 suggestions over here. Let's do one by one. Let's do the first suggestion, which will be, let's say we are still over here. Let's say we are still at this point here. Rather than just going for J directly, first of all, we have to know what values can J take. We know that J can take from 1 until imp.count. What's imp.count? First of all, it's going to be imp.count. And we know that it's going to be 3. So we know that J can be 1, can be 2, can be 3. So why don't we just manually encode it over here in the expressions? So we can say over here, imp at position. So J.item here, for the very first iteration, should be 1. And then tilde old imp. And then for the first iteration, that should be 1 as well. So this will be true. So that's telling you, basically, that for the very first iteration, it's going to give you true. Okay? If effectively, I'm really doing this, but this one is not currently allowed by the iPhone Studio tool at runtime. So that's why I'm just hard-coded the index over here. And then you can do something very similar. How about the second iteration? I don't really have to step further. I can just say over here. So now I can simply copy and paste. So now I can say imp at position 2, and then old imp at position 2. I can predict what's going to happen. That's also true. You can do the same for the third iteration as well. Okay? So that's about the first approach, how we can debug the across notation. You will just have to know what can be the possible value that a dummy variable or local variable can take. In the case of like a simple interval, you will know what to take. In the case where you might go across maybe an array contents, you have to know what the contents are in order to write expression like this directly. Okay, that's one way to go. Let me show you the second way. The second way, you will have to modify your source code a little bit by introducing something. Okay. The second way to do it is, let me just terminate this. Okay, I already wrote some code before the session, but so that I can save some time. Let's say this. I simply just declare 2 local variables over here. So let's say local j. If you can think about the local j is like just like a debugging version for the local variable j that we couldn't debug, you know, for the across. I'll type integer, so that's a loop counter. And then let's say the Boolean is going to be whatever Boolean result we're going to get for every iteration. All right. So now what we're going to do is I just need wrote some extra loop over here. Now you have to know that whatever loop you write here should be semantically equivalent to this across loop, which means we are writing something that has the same meaning. Think about what this loop is doing here for the across loop. we're basically saying for every iteration, we want to evaluate this particular Boolean expression. That is why I put this exact the same Boolean expression over here. And now we know that j is going to be from 1 to int.count. So that's why I initialize lj to be 1, and then until it's strictly larger than int.count, right? So even though it's a different construct, but meaning-wise, it's the same, okay? Let me now simply just uncomment this for now. Of course, once you finish your debugging, you may want to comment it out again, okay? Let me just compile this, okay? And then let me just set the breakpoints quickly, and then you will see what I mean. So now you will be able to do the debugging as you wish. Let me put a breakpoint right in the beginning of the from until loop over here, okay? And then if I say run, okay, so now we are just in the initialization stage. If I say step over, okay, so now we are entering the very first iteration, right? So now you will be able to actually copy, if you simply Control-C to copy it, and then Control-V. So that's exactly this, right? So now LJ is just a local variable I just encoded to map this particular J over here in the across loop, right? You can see it over here. Okay, if I do that, you can see I can definitely do it. It's simply just true, right? Let me try to just go one more iteration for you. Okay, so now I can simply just go for incrementing LJ. So now if I go back to the next iteration, you can see, so now LJ has now become 2. Okay, you can see that can be a debug. So guys, the lesson to learn over here is you cannot do it directly for debugging. You have to do either approach 1 or approach 2. Either you manually encode the value in the expressions watch in the debugging mode, or you have to encode this as a separate loop. Either way, okay? Any question about this particular slide over here? I think this question here is very practical. I think that's good. So hopefully that will help you debug, not just lab 1, but future labs or the projects. Let me look through the chat over here. Something about the previous slide. Okay, so assuming that this is, you have no question about this, there's some confusion over here about the tilde over here, right? So back to this particular slides. So when you say tilde on the array objects over here, right? So this one is really comparing the object, the array objects directly, which depends on the object comparison value. On the other hand, if you use the across loop over here to compare element by element, this tilde over here is comparing string equality. I think maybe that's where the confusion is, all right? If you still got confusion here, maybe speak to me, maybe after this session here. Guys, any question about this particular using debugger question? We okay? Yeah, so if you find it useful, you can try to reproduce and try to practice that, maybe for your lab already, if you want to debug the cross notation. Okay, the next question. How do you define the first level, second level, and so on? And also, in the lecture, I didn't explicitly talk about what if you simply change the imp, for example. What if you change the imp directly? For example, I didn't have anything like imp is reassigned to possibly, let's say, imp number 2, just another array. So what level of change should I consider this? Okay, so now let me just explain to you my terminology here. There are people simply use mine, I just use terminology used by some people there, but they might count the level of changes slightly differently. I think as long as we agree the diagram over here, I think we'll be consistent, okay? Good, so now let's see, how do I define the first level? Okay, let's say the following, okay? Let's say over here, if this is the imp array we're talking about, let me just be consistent with my color here. Let's say the imp is really pointing to this particular array over here, okay? Let's say, starting from here, we're gonna count the level of changes, okay? The first level really is, when we talk about, we try to make changes on this particular pointer, okay? So if you reassign this particular pointer, for example, reassign this to something else, that will be considered as a first level change. You're changing the elements of the array, right? That's the first level. What about second level? So you can see this particular pointer is really pointing to this particular array. This particular objects, let's say of type C1. And now for this particular type C1, it might have just another object structure from, let's say, another attribute A1. So now when you try to reassign this particular attribute over here, where you want to modify this particular object, it will be considered a second level change. So the pink one over here will be the second level, okay, and so on. You can also get the third level over here, and so on. But I would say, as far as this course is concerned, typically we only consider either first or second, right? You wouldn't go too far. There might be some complicated code you will have to write when you go to lab 3 or the projects, in which case you would just have to be consistent with what kind of level of changes you're making, okay? To recap, and now I'll get to this particular question here, okay? So if you're only reassigning this particular reference, is the first level. If you're modifying this object that's being pointed to, including reassigning this reference, that's a second level, okay? If you want to go further, you just keep counting to the third, and also to the fourth, to the fifth, and etc. Okay, that's how you count the level changes. So now the question is, how do you name this particular change? I would say, if you try to modify this particular one, I would say it's like a 0th level, really, if we want to be consistent, right? If you're only modifying, let's say, the imp over here, in that case, that would be the 0th level change. But I wouldn't be so insistent about you adopt my terminology here to say first level, second level, or the 0th level. I would say every time if you want to describe the change, you can just be precise. What do you really mean, the change you're going to make? You might say, I'm simply going to reassign this particular array member to another object. In that case, I would know you're really talking about the first level. Or you might say, I want to modify maybe the first elements, objects of the array by modifying its attribute somehow over here. So I would know you're talking about a further level of change. So that's another way to go. You don't necessarily have to say first or second, okay? Great, it's a very quick clarification for the terminology, okay? Okay, next question, okay? All right, this one is also interesting, okay? So this really has to do with this particular slide where I talk about there is a compilation error, right? Let's just review this very quickly, okay? So we said in the lecture, this particular expression over here will not compile simply because, okay, let's review very, very quickly. The old keyword over here will apply to just this expression here, right? I said in the lecture the longest unbreakable dot expression you can apply by the old keyword. So we'll only go up to here because there's a tell that. So that means it's time to break. So now that means in the pre-states, we're going to cache this particular value over here for the get j.item, right? And then get j.item over here if we want to cache this in the pre-states. So that means it's really around this particular timing over here that the runtime is going to memorize for you in the pre-states. However, j over here only exists in this particular post-states. So you cannot really cache a post-state value in the pre-states. So that's a contradiction. So that's why it wouldn't compile, okay? It's a very quick recap of what you learned from the lecture, okay? And then I'm gonna go to the question itself, okay? One thing to note, what I said in the lecture was, how can you fix it, right? The fix I suggested was this, just for this particular part, right? I would say old, let's say current dot deep twin dot, oh, actually, sorry, let me do it again. It might be nice to talk about that particular alternative. I'll get there. Let me just focus on the example your colleague was asking. Okay, sorry, I'm just confusing myself. I already got a deep twin, so now all I need to get is dot get j.item. So now this will be okay because when you say the old keyword over here, it only applies to this particular expression, which is to make a deep copy of the objects of the linear container, I believe, the linear container over here in the pre-state. So that'll be okay. And then this whole thing over here will just be the entire copy from the pre-state, deep copy. So any aliasing, any level of changes is not going to affect the pre-state copy. So we can compare them properly. Okay? So that's a fix I suggested in the lecture. Okay? I presume you're okay with it. Okay? Your colleague suggested another fix, and they're wondering why it wouldn't work. The fix is something like this: allCurrent.getJ.item. Okay, so let me write it down, and then I'll show it to you. Okay, let me just wipe it out. So you already know the change from the lecture. So let me put down what your colleague was suggesting. So let's say rather than this, okay, I'm gonna get the following: old current dot get j dot item. Okay, guys, first of all, it will compile positive. So compilation wise, this will be a good fix. If the question I ask you to do is only to fix it without being logically correct, then this will be a good fix, right? Because now the old keyword applied just to the current. So that'll be okay. We are not really using the j.item in the pre-state copy. So that's good. As far as compilation wise, as far as compilation is concerned, this is fine. Okay. So now, why would this not work? That's the question, right? Let me pause a little bit to see if anybody wants to speak up to tell me why you think this actually wouldn't work. Let me write down the conclusion for you. Number one, compiles. Number two, not so useful. Okay. Yeah, OFAC is pretty much right. Reference copy is being made. Reference copy of what? OFAC, can you be a little bit more specific? According to this particular fix over here, the current context object, which is a linear container over here. Okay, so let me elaborate a little bit more. Okay. According to the definition for the class over here, linear container. Let me just draw quickly. Okay, let's say LC is a linear container, right? It's now at the runtime it's pointing to a linear container class. I'll say LC, linear container. According to the definition here, it only contains the attribute A of type array of string. A over here, and then it's simply pointing to an array of string. Right, so it could be A, could be B, could be C over here, etc. Okay. So now, when we say old current over here, we know that the developer, the way they write the old expression will determine how the old expression will be cached or memorized in the pre-state. That's really the, what I kept emphasizing in the lecture. So now, if we only got this, so that means old keyword only applies to just the current, right? So that means in the pre-states over here, what will be cached is like this. Okay, let me just put an arrow over here, so you will know that this is the caching is done before the implementation is executed. So now, if I put it here, you can think about this is like this. I'll say old current. So there's some variable under the hood. Old current is assigned to current. Okay, the current is really the current linear container object. So let me just say this. So that means the old current now is not going to point to just the same linear container objects, right? So now, why would this not be so useful? If you can see visually, right? What if in the implementation over here, if I do something incorrect? For example, if I, for example, simply reassign this array into something that's empty, for example. Well, these, so let's say this. If I say all current, tell that current. So guys, take a look at this. If I say all current, tell that equal, let's say tell that has been, the is equal has been redefined already. Let's say you're simply just going to compare the array contents over here one by one. Let's say, let's make the assumption to make it simple. If I compare this, consider this particular Boolean expression over here, if I say all current, tell that current. So current, you can think about this as a current. So we are really talking about over here, all current is really referring to this particular object over here, right? Versus the current is also referring to this very same linear container object. So that means it doesn't really matter what kind of changes you made to the linear container. The pre-state will always be always be affected as well. So that means you can never compare the changes between them. So this will be actually true. And the true over here is actually not good, because the change made on current is not visible anymore. Yeah, when I say it's not visible, it simply means when you compare the pre-state copy and the post-state copy, you can actually not see the difference. That's what I meant by visible. Okay. So guys, let me just recap very quickly about this particular question here. It's quite a deep question, I would say, quite a deep one. So the question is, why can we not make this particular fix where you say current over here rather than current a deep twin, right? Just to make it compile, you can definitely say this. However, logically speaking, it's not very useful, and you should know why it is not very useful. It is because if you only write all current over here, all we will do in the pre-state for the caching will be just a reference copy of the linear container. And so now the pre-state copy and the post-state copy, they simply point to the same objects. So that means it doesn't matter what kind of changes you made, even though incorrect, you cannot see the difference. So if you compare them, it will always be just true. On the other hand, if you did what the lecture suggested, if you simply put deep twin over here instead, in that case, the pre-state copy and the post-state copy will be completely separate object structures. In that case, you can, if you do this comparison over here, it will give you false, which is correct, because now you can have some post-condition violation to show that you're not supposed to change anything for this particular update, but you changed something already, right? All right, so this is a slightly more complicated question there, but hopefully you can see my answer here. But any confusion you want me to clarify, go ahead, okay? Okay, let me see some comments over here, okay, from different people here. First of all, from Eric. I don't really get how you are saying .get for, even though it's a deep copy, there isn't a J, okay? I think what Eric's confusion maybe is still from the lecture. Okay, let me just do a separate page, okay? The question really is, why is this a compilation error in the original one without a fix? So now, let me make it a little bit bigger, okay, like that. This is the old keyword, right? So now we want to see what expression value is going to be cached or memorized in the pre-state. In order to determine that, we had to find the longest unbreakable sequence. And in this case, we are reaching an operator. Usually that's a break, okay? So far, we should agree that this will be the expression to be cached. Expression to be cached in the pre-states. Okay, that's point number one to note, okay? So Eric, I hope this point number one is okay, okay? For point number two, given that we're going to cache this particular expression value, so now at the runtime, this is how it's gonna go. Let's say if this compile, right, hypothetically. So that means right before the implementation, the way IFO runtime is gonna cache this would be, they simply got some variable, let's say old get J item, right? Just some variable there. And then they're going to simply say assign to this particular expression, get J.item. So now you want to think about, does it really make sense to evaluate this particular expression at this point? It doesn't make sense because the across loop is only declared in the ensure clause, which means it only exists in the post states. However, when you try to cache this particular pre-state value, J doesn't exist. because J belongs to that particular post state loop. So that's why it will be a compilation error when you do this. So Eric, I hope that's better for you. I hope. Sure. Yeah. So if you got another confusion, you can speak to me later. Okay. Okay. Another question here from Chiming. Okay. There's a J in the post state. You catch the current in the old area. Yeah, I think you're not really making a question, just making a remark. Okay, I think that's right. So we cannot use J over here, which exists in the post state. We cannot use it in the pre-state, right? It's not allowed. All right, so we still got about 8 minutes. Okay, let me see how many. I believe I don't have many left. 1, 2, 3, 4, 5. I would say something there. I'll just go one more, and then I think the rest we can continue from tomorrow. Let me just tell you something here. This has been fixed already. So there's some slight inconsistency there. So if you check the diagram, okay, let me show you this. Okay, let me just clarify this quickly. If you go to the lectures page, okay, if you go to the lectures page and then you simply go to, oh, sorry, hey, that's not lectures page over here. Remember from week 1's lecture, there was a diagram over here. Diagram. Okay, it's a state diagram just talking about how you should check, the contract at the runtime. According to it, you should always check the post condition first before you check the invariance, right? That's what we said. However, in my slides for week number 2, if you look at, should be 2B over here. I think it is maybe 18 or something. Let me get there. Okay, for this particular slides, I have already fixed the inconsistency. So now if you re-download it, you wouldn't see that inconsistency anymore. So that might also say you should always evaluate the post condition and then you evaluate the invariance. Okay, so that one, the error has been fixed already. So just want to mention that quickly to you. So if you haven't got the updated version of the slides, you can re-download it. Okay, guys, we got about 5 or 6 minutes. I would suggest I still got maybe a few more questions for the week 2 lecture. I can leave them until tomorrow. Okay, so I will finish them off tomorrow for sure. We don't have that many actually. And then tomorrow I can also talk about the exercises that I left to you from last week about how you can judge whether the post condition is valid or not. If you haven't done it, I would suggest take a few minutes to think about the answer yourself before I discuss that with you. But that will be the plan for tomorrow. But for now, I can take some questions if you got any related to Lab 1. Of course, if you got the more specific to the code questions, speak to me in person or speak to the TA. But if you got more general question to clarify, you're welcome to ask. I can stay until maybe 7 or 7:05 if you got any questions. It's up to you. Okay, I'll pause here and then I'll continue with the lecture series 2 tomorrow. But for now, you can ask me any question you have for Lab 1. Any questions about Lab 1? Yeah, if you don't want to type, you can just speak out. That's fine.